Good morning, everyone.
Good morning, Andreas. There are already people connecting, so
good.
Let's put the first slide in the front page. Yeah.
Okay, am I understandable, and is the video fine so far? It looks good from my end, but also from your end?
Yeah.
Good.
Everything is clear.
That's good.
So I switch off the mic and camera now.
Hello, good morning, Frederic, colleagues.
Hello, Javier.
Hello. Can you hear me well?
Yeah, very fine. So
okay.
Everything is fine. Video is okay, and everything is okay.
Good.
Andreas is with us. We are waiting for Jens, and then we are waiting for 10 o'clock to start with.
Okay.
Yeah.
Okay.
Perfect.
I switch off now mic and video in the waiting.
Okay.
Same here. Thanks.
Dear all, welcome to this first webinar, which is dedicated to the operations rules which are linked with the development of the digital automatic coupler in the frame of the full digital freight train operations, which is a game changer project within the European railway framework for the freight transportation system. So we are today with already 90 people connected, and I think some still are connecting at present. So I propose we start, and let's start smoothly with the, I would say, a reminder of the behaviors to be considered during this webinar, so that it's possible to run with a smooth and understandable webinar. So as a matter of information, this meeting is obviously recorded, and the videotape of this meeting will be made available after this session, as well as the support which is going to be presented by the presenters of today that you are going to be speaking with afterwards. So as well, please keep your mic and video camera off, so that it will be possible for us to optimize the link with the internet connection and the presentation of the slides, which are very understood. On the chat is made available for you all so that you can ask questions or make any remarks. The thing is that on the chat, this will be considered after the webinar to be integrated into the online questionnaire that will follow up this session of today. But for this questionnaire matter, I will describe the thing at the end of this webinar to explain the way that we are going to run forward the actions after this first session webinar. May I start by reminding the main objectives of this first session of today? The purpose is today, first of all, to deliver the first set of preliminary target operational procedures in the frame of an harmonized railway system. These harmonized procedures are developed thanks to the different activities in the EU Rail project that are going to be described in the frame of uniformity regarding the technology which is developed, and with as low as possible complexity level. So it means with a easy integration into the railway system and come to the market in order to be efficient in the frame of the change of the railway system. Then the first objective of this webinar is for you all to have a better understanding on the way to read and to understand the report which has been provided a few times ago. 1 month ago, it means from the FP5 WP2 activity and Andreas Haller team. And this, of course, will be more precisely described in the frame of this first webinar. So let me allow as well to give you a kind of timeline for this webinar. So as an introduction, Mr. Javier Ibanez from the Europe's Rail joint undertaking as a senior program manager will make the introductions to remind the, I would say, activities related with the European Commission and Europe's Rail project. In the frame of the European DAC delivery program, Mr. Jens Engelmann will as well remind the different contextual and considerations to be taken on. Then we will go deep to the content with Mr. Andreas Haller, who will explain further the first delivery of the technical report, and then the way to understand and to be able to have a first look on the operational procedures. Then I will precise the way forward from this webinar with the sequence of actions which are going to be organized so that we get and we collect feedback from the World Railway community so that it will allow us to perform some drafts of rulebook related with the DAC. And then as a concluding session, Mr. Jens Engelmann will finalize and close the session. And of course, with this first webinar, we intend to get connected and actively connected for the, I would say, progress of the integration of the digital automatic coupler into the rail system. Then this is, as an introduction, the agenda for today. So I pass the microphone to Mr. Javier Jimenez. Javier, the floor is yours.
Yep. Thank you, Frédéric, for the introduction. I hope you can hear me well. So I will start. Yes, I will start with the first slide. Thank you, everyone, for joining today the webinar. And as Frédéric mentioned, the intention is to disseminate this technical report provided by FP5 Transformer project within the activities of Europe's rail. And for those of you who are not very familiar with the activities of the Europe's Rail Joint Undertaking, just to mention that is the successor of the Shift to Rail Joint Undertaking program, and Europe's Rail is established by the Council regulation that is in place since November 2021. Here you can see in this summary slide the Europe's Rail vision, giving you an idea of the many challenges that we have ahead and how we are aiming to achieve faster uptake and deployment of projects and innovations. And for that, we have to, of course, exploit the potential for digitalization and automation, which is one of the aims of these digital automatic coupler activities we are doing within Europe's rail in order to reduce rail's cost, increase its capacity, and, of course, enhance the flexibility and the reliability of the operations. And, of course, how it should be done based on a solid reference functional system architecture shared, of course, by the sector and in coordination with the European Union Agency for Railways. This is represented, as you can see here, in the Europe's Rail Organization, together with the key operational aspects of the focus areas. As you can see, these activities or main areas considered within the innovation pillar have to do with the European rail traffic and mobility management, the digitalization and automation of the train operations, of course, sustainable and digital assets within FP3 and FP4 for the competitive digital green rail freight in FP5. And we don't forget the regional rail services to go through these low density areas, and which is the scope also of the activities within FP6. These five focus areas that I have just described set the framework for the scope of the system pillar, which also aims to guide, support, and secure that the work of this innovation pillar is ensured and is targeting common, agreed, and shared customer requirements and operational needs, as we will later on describe within the content of this technical report. And of course, how these operational procedures are compatible and aligned to this system architecture defined. Not to forget, of course, the deployment group activities that will, of course, bridge the research and innovation to the future coordinated activities for this deployment of solutions at European level. Just also in a nutshell, and in the next slide, you will see that in order to achieve this transformation of the railway system through the Europe's Rail research and innovations, we aim to, of course, consider the sector as a whole, supply industry operators, infra managers, and the research community, as you can see in the next slide, Frédéric, please, on the Europe's Rail multi-annual work program that touches upon 7 different flagship areas that you can see summarized in here. Of course, touching upon exploratory research. Some of the milestones are included in the sustainable and smart mobility strategy that, of course, implements the European Green Deal and specifically includes the increasing of the high speed and freight traffic by 2030, with the significant impacts that this has to reach the goal of climate neutrality for rail transport. So in this sense, and if we also go through to the next slide, please, you have here in the flagship multi-annual program, the flagship area 5, dealing with freight activities. And here, just to summarize a bit for you, the project fact sheet of FP5 transformer. This is the activities that were granted funding from the publication of the call in 2020, in the first call of the Europe's Rail JU. The starting date of the project has already started back in July 2022. And you can see here a bit the general technical contribution, the reporting periods, so the periods in which this project will be active, and of course the number of participants that, as you can see, and you will see later on detail in the next slides, is comprising from railway operators to all the railway stakeholders involved in these key activities for boosting the freight activities. Also here you can see in this slide the summary a bit of the project. As you can see, this was subject to the consortium agreement that was concluded already back in 2022. And the project focuses on two main work streams, being the first one, the full digital freight train operations with DAC as an enabler for the full digital freight train operations. And here you can see the different TRL levels in which these key activities will be focusing. The second work stream, and we have also later on made it a bit more clear for you in a slide, is touching upon the seamless freight and how having this easy access or having this easy access and reliable intermodal transport services will make the freight operations be boosted, considering all the key elements that you will see later on a bit more detail in the summary slide. Next one, please. You can see here a bit the integration of how FP5 is integrated within the organization of Europe's Rail and the links with the system pillar. And in the next one, you can see the technical enablers that the flagship project 5 transformer is working on, from the interoperable DAC type 5 ready, and for the testing on all those activities that you can see here and that are described, of course, in the actions of the project. To finalize and not to be not take too much time from the presentation and from the key activities of today's for the main action today, that is to provide the details on the preliminary operational procedures provided by FP5. You can see in the summary slides on how these work streams and how these clusters are contributing one to each other. In the next slide, please, Frédéric, you can see indeed how this full digital rail freight operations, considering the digital automatic coupler, the automatic shunting operations, and the automated train functions, together with the activities dealing with the automation of yard equipments, are somehow linked to the seamless rail freight activities on the workstream 2, to have this multimodal and logistic transport chain included in the operations, and of course to provide this seamless planning and dispatching, together with the integration and prediction of operations within the network. So in that sense, this is what FP5 is touching upon. A lot of work ahead of us. You will be learning just now from Andreas a bit more details on this specific operational procedures first version that has been delivered, but and then from our colleague Jens on more the details on the DAC activities within the ADDP, and which are of course combined and synchronized with the activities that together with the system pillar we are carrying out in Europe's rail. With this brief summary on the activities of FP5, and waiting for maybe additional questions you may have at the end of the webinar, we remain at your disposal. And I pass now the floor to Jens. Yeah.
Good morning, everyone. Same question as for Javier. Can you hear me? Yeah, understandable. sound works. Many thanks. I see that 262 participants are in this webinar. This is incredible. We are so happy about this, and this shows already that the idea of having this kind of dissemination consultation is a good idea. And what I wanted to show you today here very briefly is this context, why we come to you and in which frame and with which actors. And Javier has shown you the internal structure and the project names and tasks from the Europe's Rail Joint Undertaking. And if you may, maybe the next slide, a very simple thing, because there's this animal European DAC delivery program. And you are certainly interested how this works together with the others. And this program has two program managers. The left one, best regards from him, is Mark Topal, actually, who is the CTO of ÖBB. The right one is me, and this is, I mean, Javier and also Giorgio, and we are more or less one team, yeah? And we are taking care of the daily management of the delivery program itself. And now the question, what is this and how are they connected? So if you please maybe could move on. Exactly. And the next slide shows you at least the European actors on this. The left here is this building in Brussels in the Avenue du Toison d'Or. And there is the joint undertaking located, and there is the transformer FP5 project located. All this what Javier was just mentioning, the innovation pillar and the system pillar activities. Also, the European DAC delivery program is hosted there. We are enabled by Europe's Rail. So if you want to have a kind of mail address, you can find us here in the building of the joint undertakings in Brussels. In the middle, we have the DG Move, which is one of the players here because we talk about legislation, we talk about TSIs, we talk about all sorts of political support and stakeholder management. So, I mean, this is a bigger transformation of the whole railway system that we intend to do here. So it's clear that the Commission is involved. And same goes for the right side. I see many of my old colleagues in the webinar today, very happy. Hello. The European Union Agency for Railways, the ERA in Valenciennes, because they are in charge of writing the TSIs, but they will play also a crucial role for the whole question of authorization, and certainly later on the operational procedures. I'm looking at TSI operation or whatever might come up there. So these are the European actors. And if you move forward one page, please, you see how we have arranged that organization-wise. On the left side, there is this flagship project 5 with all the things they develop from operational procedures to the products and later on to the authorization dossiers and files. Left part of the picture, this was all that Javier has just explained you, and this is this full digital freight train operations part. This is where DAC technology, the coupler itself, the automation, digitization technology around is developed with the project budget that Javier has mentioned and all the participants, over 70 partners, I think. In the middle, you have now this EDDP, the European DAC delivery program. I always say our task is to organize that the money can be collected and spent wisely later on for deployment. In earlier times, when technology was still a part of the EDDP, as on a voluntary basis, we had all together, but now with a big budget, the technology development moved to the FP5, and in the middle we have this mainly what we call migration roadmap, DAC migration roadmap. And you see the green boxes here. We have to take care of the analysis of the fleet because we are in the rarest cases in a greenfield approach. We are in a big brownfield approach. We have about 450,000 assets, running assets, rolling stock assets to upgrade, to retrofit one day. Maybe a little bit less, but in any case, many. We have to check in the middle of the box the capacity for the retrofitting, the workshops, how can we, and so on. Also later on the question if the pop-up workshops for Big Bang elements and so on, where are they? retrofitting plan, which vehicle will be refurbished, where, at which point in time. You see down left, on the left side, you see safety, workforce training, rule books. That means inputs into safety management systems. It's also touching the agency's work. There's a lot of things to do. And then here in the middle of the picture, funding and financing plans, CBA, investment plan, procurement plan. This is how we would then deploy this. Partially, this is a mixed work between the agency and commission and us, because the development of these suitable authorization, I mean, the process is existing, but the correct provisions that the agency is working on, what they call massive retrofit for our cases here, the work is closely connected and very closely connected, especially to the FP5. And then, of course, the commission, who gives a kind of general umbrella for all this. The Europe's Rail System pillar, which hosts today this webinar, is then later on, when they are done, responsible for the standardization and for putting all this out to the world on the right side to the European standardization organizations, or wherever this is deemed useful. And this is then also where it touches you as visitors here, as participants to this meeting, because one day this will become then somehow a standard. We will come back on this in a moment. The next page shows you that the EDTP has always been already not that badly represented in terms of actors. We have a lot of companies. Some have moved into the FP5, but are still active in the different work packages of the EDTP. And so we have stopped counting by the end of last year, but I mean, they are still all there. That means you see the huge interest. And I personally think that you are here in this webinar either a member of one of those companies or organizations, or a new one, which then confirms the interest. Because on the next slide, you will see that we have a governance structure, and this is especially the program board. And you see that in this program board, not a lot of sector members, of very relevant sector members, is represented. Railway operators, wagon keepers, industry, of course, commission, agency, and the joint undertaking who runs that all. But in the end, this is also only a kind of selection. It is a very representative selection, but it's not the whole world. And this program board is taking some decisions. And then we said, and if you maybe can move to the next slide, I said here on the left side, we have the development of the technology, as we said, but this is under a grant agreement. This is under a contract, and they are bound to a certain level of confidentiality. They cannot say every day what they have invented now and where they are with the results. So they have to do it from time to time. And this is, next page, please. When then later on this operational procedures and that stuff that precede all the work shall be standardized, there might be something missing, and this is the feedback from the rest of the world. And with this, I come to my last slide. This is why we have arranged these sounding boards. And there are sounding boards on operational procedures and sounding boards on technology. And this is a kind of intermediate animal where we, as today, come to the world and say, hey, this is the status that FP5 can present to you. And maybe we have not respected anything. Maybe we are missing something, but one day the system pillar and UIC then will do the standardization of this work. And it would be better to know in advance than later, and then maybe too late. And this is why we have this series of operational procedures webinars. There are others for technology. You will find them on the joint undertaking website. And there you can also register if you want. Then you get the invitation. And with this, I think we can then move to the content, to Andreas Haller. And for the DAC use cases, I think we can go very quickly. This is already Andreas' part here, I think, yeah. So this is the framework for all of this. I'm very happy and looking forward to your comments, and then Andreas will be happy to take this all into account as much as possible. We wish you a good seminar. Thank you.
Thank you, Jens. So the floor is yours, Andreas. So up to you to share your screen to go through the content-wise, because now we are going to speak techniques. So you are the man.
So I hope you can see the screen now again.
Yes, good.
Good. Then let us start. So also hello everyone from my end. Let me briefly introduce myself. Yeah, my name is Andreas Haller. I'm working for DB Cargo. I'm at DB Cargo, the lead architect for the intelligent freight train and the digital automatic coupling. And within Transformer, I'm leading the work package that obviously has to do something with operational procedures, architecture, and also with the requirements management. So I'm that will guide you through our beloved document, the preliminary operational procedures. And to start with, let me briefly tell you a bit about the document itself. So it is called preliminary operational procedures, and this is, yeah, you might wonder why preliminary. Yes, because we at Transformer in the project obviously did a lot to adjust and agree on these, what we will present to you, and what is then in the 300 and over 300 pages that you had already the chance, hopefully, to read or to have a look into that document. And but they are still preliminary, and this is why, because we are looking now for your support, for your feedback, for your input. And of course, as Javier explained and also as Jens said, we are constantly working within Transformer on the development of the DAC and the full digital freight train. So, and this is why obviously we have to adjust here and there different means of the operational procedures as well, because there's a high link between the technology that we invent and the operations that are possible with this technology. So this is why we have here the first iteration that we want to bring to a broader public. This is why we're here today. And so I cannot mention it enough how important that is, that we now gain more feedback. And you will see in a couple of minutes what we already did in advance to agree on. And also Jens explained, just explained that we have these sounding boards and so on, and we will come to that again. So, but what you will find, and I hope, as said, you already had the chance to have a quick look into the document. I know it is not easy to read. It's 300 pages long, and you really have to take your time for that. But I really urge you to do so, because it is important. Because as also Jens explained before, at the end we will derive from that the rules for us in Europe. And so now is the chance for everyone to be part of that story and to give his or her input, so that we have really an agreed European-wide procedures document as a basis for the rule set and for Europe. So I will guide you through the document and point you to the most important bits. At the first beginning will be, I would say, the more boring parts, I have to say. So all these kind of nasty things like descriptions and definitions and so on. But this is really important to understand then the main chapter in the document, which is chapter 8, where really then the processes are described. So we need that in advance to really understand why the people, the authors, described it like that. And so this is really necessary to do so. Also, what I cannot do in 90 minutes or something, we cannot browse through all the processes, obviously. So that is not possible, but I will give you some guidance on how to read so that it is easier for you to understand and give you some kind of hand so that that you can understand and see, okay, this is how they understood, this is how the methodology works and so on. And of course, one walkthrough to one example we will do together, so to see, okay, how is this working? So, and this is then where we start with chapter by chapter, more or less. And the first chapter obviously is always, so what is this document all about? And I think that's the first takeaway here. So we have here the first agreed target operational procedures for rail freight. And I think that is a major step forward, and you will see who agreed to that already and how we want to do that further. But I think that we anyways succeeded to agree on some kind of operational procedures first time. I think that is a major step forward, and it also makes obviously the development of the hardware better and easier, because we have one hardware for whole Europe, and I think that's a really good news for everyone. Then also stated now, this is the basis for our development in Transformer. So you have here work packages 3 to 12 because it's directly out of the document that you also have. And these work packages are the structure we have in our project. And these are the work packages which really taking care of the development of the hardware and the products. And also very important, and here this is, we will come to that also later in detail, the difference between the different views that are in the document. We wanted to, and we did so, to describe the target of full automation of the freight sector. So it is not only a part of the story, we wanted to really give a big picture of how we want to do our business in the future in the freight sector. So this is why we call them also from time to time target operational procedures, so that we said, okay, this is where we want to go with full automation, with the freight, with the technology that we see. But you will see this is more that is maybe available in the next couple of years. But it is important to draw the full picture at the beginning to see, okay, this is where we're heading in total. And now let's slice this into pieces and put it on a timeline. So this is the main part. But of course, we have, since we are here in a project from ERGU, and we have, as you learned before, a grant agreement to fulfill. We have agreed on technical enablers, so on topics, on things, on products that have to be developed and within the project. And for that, this is, of course, we cannot reach the target of full automation in the next couple of years. This is why we have a subset of processes also described again. So it's the same processes, but they are enabled just with the technical enablers, so that you can see what is the deliverable of FP5 Transformer from operational point of view, what is possible with the technical enablers that are coming out of FP5 Transformer.
Andreas,
May I intervene, Andreas? Is your screen frozen or not? Because on the presentation mode, we are still on the chapter 1, 2, and 4 slide.
Yes. No, it's correct. Now
It's correct. Okay.
Oh, okay.
Sorry.
Good. So the next thing is, since we started here with the introduction here, the next main chapter that we are focusing on is the background, because also we learned this today beforehand. We were not starting with a transformer from the beginning, so from zero, you know. So obviously there was a lot of other projects, initiatives before a transformer that were important for also operational procedures. And so what we did, we collected what we had in stock, and also what we gained from other projects, and of course had a deep look into that, digging everything out that we could learn also from project like DAC for Europe, for instance, where we already learned how to interact with the system and so on, but also from Accelerate, EDDP, TIS, and so on, so that we combine all the knowledge that was already there with what we want to do, and then develop together in FP5. So just to be clear here, the stuff that was done before obviously was not neglected or whatever, and we did not forget it or say we started from the beginning because we are in a new project and we start from scratch. No, we took all that and put it on the desk, and then sorted it out and brought it into our operational procedures. So all that should be reflected. If you're missing here something, or you said, did you also take care of that, and so on and so on, please give us the feedback here also, and we check if that is just not mentioned, but we have it from maybe from another perspective, or so that we see that we have here a sake of completeness. So I was talking a lot about and so this is a bit now how we described and how we delivered this kind of document. And Here, we formed a so-called core team within the project, which was then responsible for writing the 300 pages, but also really creating the content of the 300 pages. And so just to mention here one time, because I think they did a great job, this is colleagues from DB Cargo, so Manfred Stobrabe, Stefan Zebracki, my two students, Anton Vogel and Lisa Ruiz. We have from RCA, from the Rail Cargo Group Austria, we have Barbara and Manuel. And from SBB Cargo, we had Aldo Svania. And last but not least, obviously, we had Patrick Lefebvre from SNCF Fred. So these people were the people who were then really writing down the 300 pages, were creating the content, and took all these content, and we're rediscussing that with multiple people all the time, back and forth, so that we at the end came out with the document that you now will find. And you might say, okay, and how did they do so? So how did we do it? So we have these famous shells, let's call it like this. And we at the moment here in FP5, we started here. The operational procedures core team created the content. So the first stuff, so that we have something to discuss with the broader audience. And the next step we always had was obviously to discuss that within FP5 in our work packages, but also with other partners within FP5. So within the project, we discussed, okay, is that doable? Is that what we want to achieve? Is that okay with all the partners within the project? All that has been discussed within these steps. Also, not to forget to mention here, even though they are not mentioned here within Transformer, we also have the industry partners with us, and so also industry partners were included, obviously, directly into the discussion. So there was a shortcut always also industry partners to see, okay, what we designed within operational procedures, is that somehow doable? Is that does that fit? Where are the back and forth, and so on? This is also why we then ended up more or less with these target process procedures, which are more or less that what operators and so on want to have at the end of the game. And we have that the ERGU transformer processes, because these are the what industry partners said, okay, that is also what is within the grant agreement and can be delivered. Then also we touched upon this because Jens already told us, we as a next step of pushing the current state to a broader audience, we were in multiple EDDB sounding boards, and were promoting what we already had. And the people who were in these sounding boards, I think they also saw that we had some kind of change in how we presented it. At the beginning, it was just some sketches and so on, and it got more and more mature, and also more text, and it was really ramping up. And now today we are here at the system pillar ERGU, so in the big circle, because now we say, okay, we have something which is really complete, which is a good first draft, and now that push that to the broader public, and this is where we are today. So in the system pillar, which is really now addressing more or less everyone to contribute and also to give feedback. And this is really what we need, because as stated here, as you see how we evolved here, we really need that kind of feedback, because we did everything as good as possible, but there is obviously all the time back and forth strategies on the one on the other topic. So please be part of that story and give us your feedback. Good. So that is how we did it. And I also said a couple of times we have the operational procedures, but and here we are jumping a bit chapter-wise, but still I think it's important to put it here. Not everything is, of course, in this document, or I would say not yet. Yeah. And the first point which you might wonder is, hey, they are not just everything should be fine there. So they are just talking about good cases. Yes, at the moment, that is the case. At the moment, we think when we activate or do something, everything works according to plan. So the disruption and error processes are not yet there. We will have a version of these error processes available in the future. So we will give here also some kind of guideline, but it is here really, a really complex thing, because normally these kind of disruption error processes are really focusing on the various site, on the company that doing that, and so on. So to come here with a generic view is some kind of not so easy, and we will see what we can do here. But of course, the error processes, when it comes to the system, that of course will be designed. When it comes to operation, we will see how much we can give here guidance, what is possible within the framework. Then also, and this is also a very important bit, migration. And I know a lot of you are looking forward to migration and the answers to the questions, how we want to do that, and so on. At the moment, and I really I can tell you, the guys are really hardly working on these migration scenarios, and are really working hard every day so that we have a good migration in the future. But at the moment, since we are changing so many variables at the moment still, it is not yet possible to describe here the migration and how that reflects on operation, or is there a step in between or whatever. So migration also knows the document. Obviously, they were also involved in writing that, so they were having already the earlier versions and so on. So we are in discussion, and we are looking forward once they have something, and then we will see what does this mean for the operational procedures document, and then we will update the document as fast as possible, and then inform everyone again about this. But because this is definitely will have an impact, we already know that, but we have to give them a bit more time so that they have a chance to also do so. Then border traffic, handover between countries and/or infrastructures. So also something that is, from operations perspective, an important fact. So when we cross borders, it's a very specific task which is not yet addressed. So if you're looking for that, also give us a bit more time. At the moment, it is not included in the document. Then also, because as stated a couple of times now, we already are at 300 pages. We did not describe any existing operational processes. So when it comes to ETCS or whatever, this is fully described in the various documents that you might have already have. And so this is why we completely took that out to keep it focused on FDFTO, so the full digital freight train operation, and not blowing the document even more with this kind of basic information. So we were just focusing on what do we need to explain the new processes, and all the, I would say, stuff that is currently in service is not part of the document. Another important thing that you might look for, IT interfaces. We are talking here about a digitalization project, and obviously we will have a lot of IT stuff, IT technology in place, and also in the future system, and there will be a lot of IT interfaces. Here, due to the current state of the development, these interfaces are not yet fully designed, and so we just mention it there where we are sure that that will be there, but there will definitely be more. And also we will then describe in a future version, because we can then reference on other documents a bit more thorough that what is meant with these specific interface, and have a link to that. At the moment, we're just mentioning here there will be an IT interface, and that's it. So it is really a basic view at the moment. Also to keep it generic, because we do not know yet if there is a full-blown IT system or what in the backend or not. Then maintenance processes, also something that is really important for us in the future, obviously, because we have a lot of new technology to maintain. Here, due to the fact also that we are still in development, it's kind of hard to describe something that you not know how it will look like already, how you do maintenance. So we have shunting processes, okay, of course, but the repair processes are yet not considered, because as stated, we need to have more or less the products first. Obviously, maintenance in general is part of the discussion, and we already looking, or we be pushing for good maintainable components, that's for sure. And then we have, last but not least, the consist functions. So we have train functions. We come to that in the next chapter when it then comes to the definitions. We will have train functions, but we also have consist functions. And consist functions are more or less functionalities that are really only happening on the consist, so wagon, more or less, or local, depending where you are. And these are not described in this document because they are happening, but they're for operational sakes. We know that they are there because otherwise we cannot interact with the system, but they are not described in detail here in this document because we wanted to focus on the interaction with the systems, on the operations. Good. That was the first bit, and now we come to the terms and actors. And I know at the moment it is a bit, I would say, dry because I'm explaining a lot, but this is really important to understand. And before we really have a look into, because otherwise you got lost. Sorry. So next one. FDFT. We touched upon this a couple of times today already, and I also try to use the full term all the time. But now, since we come to the definitions, you have to live with the abbreviations all the time. So FDFT is the abbreviation for Full Digital Freight Train, and describes what we want to achieve, as the name says, a full digital freight train. And we took this abbreviation in front of anything that will be newly developed to also have a difference between other systems. You will see that why we did so. And then obviously legacy is what we have today, what already exists and is already available or in use. So that this is also clear. Good. Let's start with FDFT function. So the function, FDFT function, is a term that we use in the descriptions of the processes, and this is why we also need it here. It's a very generic term, so that we say it is a function or functionality that does not exist, but needs to develop to achieve our target state. And we will step by step see how that builds up. And one of the functions, for instance, is the FDFT functions prevent coupling, a very important functionality that we have with our FDFT train. It is what maybe you heard about, this is buffer position or something. You might have heard this term. It's more or less the same. We called it now prevent coupling. So a functionality that is activated, that the DAC coupler head must not allow coupling. So very important, because as you know, the Schaffenberg design is designed that the coupler always couples, which we are looking for. But there are situations in operation where this is not a good idea and we need a different situation. And this is why we have the functionality prevent coupling. This functionality we need on all levels of DAC. Also, we come to the levels of DAC later. So you might have heard already there are different levels of DAC, like 4, 5, and so on. And here, just to also make it clear, here the technical solution of that can, of course, look different. So, but the functionality is there or will be there or is required from operational perspective. Then we have FDFT system. As we learned before, FDFT means not developed, so new. So a system that not exists today and need to be developed to achieve the target state. So we have functions and we have systems. It's always you see it might be easy for you to understand, and so you say, okay, I think you see the logic now. Then we have FDFT wagon-based system. And now it's really an important one. So because, we want to digitize the full freight train. And obviously, then each wagon needs some kind of technology, some kind of system on that wagon to control the components, to control the new technology and so on that we want to bring in to reach our automation goal. And so that is what we call wagon-based system. So this system that controls even that components and can communicate with the FDFT link. And the FDFT link, so the network, or you can call it bus system or whatever, is connected to the other wagon-based systems, obviously, but also to the traction unit, and maybe also to the backend or landside system or whatever. So that we just mentioned, you can see that on the picture here, you have the FDFT systems, maybe outside system, landside systems. You have legacy systems that are somehow connected, and then you have the FDFT. So here, the train, the new one traction unit wagons, maybe another traction unit, and they are linked over various links of FDFT links together. Just here stating that we, of course, include legacy, we include FDFT new systems, and everything is somehow connected so that we can get the most out of the data generated here and also have everything available where we need it. Then the next big block, and there are more definitions in the document you will see, but we are focusing today just on the most important ones, is FDFT mode. And so modes, why have we modes? At the moment, we have exactly two, and that is I would say, solid start. And so we defined modes because we said, okay, we have operational situations, and there are two, I would say, different ones. We are in the shunting mode, which you can see here. We come to that in a minute. Or we are driving around. So this is the train run. So we are moving from A to B. And these are completely different stories from operational point of view. And in consequence, maybe it's a good idea, and this is what we're currently discussing and what is now implemented, is to not have every functionality that I maybe need for shunting available in train run and vice versa. So this is why we created these modes, to just also make it transparent that we have here a shift in maybe command, maybe a shift in responsibility and so on, but for really to just show that we have here functionalities not available, and in the other case it is available. How the cut will be, this is up to discussion. There is, on some parts, it's a clear picture, but some are discussable, and we are still here in discussion how we want to do so. And also here, you will read in the document the current state. But if you say here, I don't see that because I want to have a functionality there and I need that desperately, otherwise my operation is jeopardized or whatever, then please give us feedback here. So FDFTO mode train run is that the coupler heads of train cannot be commanded to uncouple. Very, very important. So that when I'm driving around, I cannot by incident push the button and uncouple some wagons or whatever. So the power supply, also very important, can now be enabled by the traction unit. The operational train run is carried out in the FDFTO mode train run. So very important. So when we are in doing really the operation, then we are in train run mode and driving from A to B. And then, as stated above, all the stuff is deactivated. And here we are really touching upon already on the topic, automated parking brake cannot be activated. But this is the state of discussion. And here really We also need a bit more, I would say, feedback, what you think about this, and so on. So you will read in the document about the automatic parking brake more deeply, and then you see if you need that in train run mode or not. Then we have FDFTO mode shunting, and here really to make it clear, it is not ETCS shunting mode. Yeah, this is where we also really took another term for that. Here we have, of course, more functionalities activated because this is what we're looking for. So we have electrical uncoupling, obviously. We have no electrical power that will harm our people on the DAC. So we have checked that everything is safe to operate, and we have the power that can also be applied in the shunting mode. We have to check that if that is possible, but it is optional. Be possible to also, I would say, load the batteries if you want to also in shunting mode. And of course we have, which is not clearly mentioned here, we have the functionalities available even more than we have in the train run mode. Good. Next block that is important is the topic of brakes, so of braking. I think service brake is something that most of you should be aware. This is something we have today. I think nothing that I should mention here. It is exactly like that. We just, because we use it a couple of times, we put it down again. And then I think more important is here the legacy braking means to secure wagons against rolling away, because this sentence, secure wagons against rolling away, you will read a couple of times within the processes. And this is something that we created from a generic point of view. We had to find a solution for that. So we said, okay, means of securing against rolling away, so that you have the full possibilities, whatever can be. So we have drag shoes, we have hand brakes, we have track brakes, and so on. So everything that is available at your very side, at the site where you're operating or whatever, just the sake is always the same. So we want to secure the wagons against rolling away, and this is what we have here. And then we have new definitions, and I think that's an important bit. We have these automated parking brake, and this secures the wagon against rolling away. And the activation of applying and releasing is done via the FDFT link. We saw that before. So a parking brake that can be controlled from the train, but also from the outside. I think a very important bit. Currently under discussion how that will be done on a technical point of view, but from a functionality point of view and from an operating point of view, that is the description. And then we have, yes, Jens, I see.
Andreas, yeah, just a short question, because we have questions here in the chat, and you told me before that you would maybe have enough time to go about them. Do you want to take them at the end or now?
I would prefer to take it at the end if we really have time, and then I'm happy to answer if that is possible, because otherwise that we struggle at the end with the content.
Yes, it's okay. So that means also for Frederick that we record them, and in the worst, in case of.
That was announced at the beginning of the webinar, so maybe some people were not connected, but the chat will be used to collect all the questions, and answers will be delivered definitely after the webinar. If we have time, maybe Andreas will answer some of them, but we cannot afford with answering all the questions which are there, but all the questions recorded will be answered. And I will describe the way we go forward afterwards. Don't worry.
Okay.
Carry on.
Good. Then, yes, I was, really, we really want to, and we will answer every question. So be sure of that. And let me just continue. And if we have time, I'm happy to already answer a bunch of questions. So controllable brake. This is also something that we newly described or newly defined. And here there's two situations. We have securing the wagons against rolling away, again, what we had above, but here, of course, with a controllable brake, as the name says. And although the targeted braking of the wagon, so standstill takes place after the wagon set has separated from the traction unit. So if you find these terms in the description, I think at the beginning it's maybe a good idea to print the table out and have that aside of you, so that you understand when you're reading the definitions for the first time within the processes, that you have that on your hand, because that might be confusing from time to time. You say, okay, because you might have a different definition in mind or whatever. So this is based on this definition, and please take that one to understand the processes. So just one slide, and then we have done the definitions part. We needed something to describe, you know, the situation that we have two couplers are coupled, and to specifically describe, okay, what is this? Yeah, this coupling point, we called it, yeah, because that is important to understand, okay, what they are doing now in the operation. So, and we called it coupling point of shunting composition, because we are in the shunting situation. And it's really just that we say, okay, this is the specific point of these two DAC coupler heads that are planned for the coupling, or in the case of uncoupling, that we want to uncouple. It might occur that you say, hey, this is really, yeah, but we need a generic view of describing that. Of course, if you have a wagon A, B, and so on, then it gets easier. But still, we need to define that, and this is why we introduced these two definitions. So nothing complicated, just a generic way of describing that exactly point. And as stated here, there's more definitions. Please have a look in the chapter 6, as stated. When I would do that, and I also do this, I have the definitions and actor stuff on two printed outs pages here, and then I can read directly when I need something. That is easier, or you have to just find it in the PDF, so that you can, of course, search through the PDF. This is also possible. It's generated like that, so that should also be an easy way to understand, but you have to anyways jump back and forth, so maybe that's a good idea. Good. Then actors. We have defined actors because as you will see then later in the description of the processes, we have some kind of a swim lane, a way of describing it, and each and every actor, of course, is one part of that story and interacts with the system, or is part of the, or is the system. So these actors are used as the executing entity. So here again, hitting us very hard is that we have various infrastructures and different RUs and so on. So we wanted to really keep it as general as possible. And so you might think here, okay, this is for us, it's different or whatever. We try to really cover it as generic as possible. Here also, if you have a main doubt about this and you say, yeah, for us it's completely different, then please approach us. But I think for a start, it is kind of okay that we called it like these generic actors that we have now to make it adaptable for everyone. And these are the actors we have a look in now, and also which are available, of course, in the document. That's for sure. So, and some of them, I think it's very easy. Yeah. So brake test operator is the on-site personnel performing the brake test. I think a very easy one. That's more or less it. Yeah. We have the consist, and we touched upon the consist definition or about the consist in the beginning already. And here, because I know there's already some discussions ongoing, please, this is the definition of consist we used for the document and also for describing the content. And for us, the consist is the smallest railway rolling stock entity for operation. Very important one, containing one control unit, so one computer that controls that, which represents one node on our network. And it can be a traction unit, it can be a wagon, it can be a set of single wagons, then as a segment. And so this is what we say that is a consist, and this consist has a unique vehicle identification number. So I think here we are back together with the overall discussions, but there is a slightly different one flying also around from consist. In our view, this is compatible with both, but you have really to be careful when you read that consist definition. This is why I'm taking here some seconds on that. So please read that. This is what we define as consist. Then FDFT backend. Again, FDFT means we have to newly invent that. So this is what we at the moment put a bunch on that and say, this is the collection of new FDFT functions on land side. So because we do not yet know how the system will look like, but we are 100% sure that we need something like that. And we are working on that, not in FP5, but in other parts to discuss on how we can do so. So especially with the system pillar at the moment. And that system will provide and receive data and will interact also with our FDFT. And that will have maybe functionalities that will steer coupling, uncoupling processes, and so on in the target state. But how exactly that system will look like and so on, and how it will be interlinked to the legacy system and so on is not yet clear. But we know we need some kind of entity that I would say interacts with all that, because this is, of course, not yet available with our legacy systems. So FDFT backend is more or less the big computer at the end that steers the full automation processes with the FDFT. And how and in detail exactly what functionality will be defined later. Then we have FDFT yard. I think also comparable. So FDFT again means new. So the infrastructure based on our elements in this area. The yard, FDFT yard, the current state of infrastructure to our backend. So this is again the link between both, and in the linking FDFT link, we also had this together in one box, if you might remember beforehand. So the interfaces here, as stated already, between FDFT yard and backend, we will define in a later step. And so once we have a basic idea on the back end, we will have a look in that again and define then the interfaces. Then you will also read that a couple of times, mobile HMI, so a human machine interface HMI. We also put here a generic placeholder for any means of locally or remote device for our personnel to interact with the FDFT systems, because we do not know yet how we retrofit, how this will be integrated and so on, but we know we need something that the personnel can interact with the system, that's for sure. And so we put it in a very generic note and said mobile HMI, so that we have something to interact, and how this would look like in specific and so on, we will define later. But we know we have something, and this can then connect to our FDFT systems. So this new invented systems can be wireless, physical, whatever, and we can connect to the wagon-based system or the whole train. Genau. So then the operator of the traction unit, so the personnel that also maybe then later remotely controlling our traction units. I think also not something special. And then we have personnel, and this is something we created. This is not originally there, but as you see here in the explanation, we have, and you will see that later, we have sub-processes defined. And sometimes we are coming from different various processes above, and so the real actor may be different. So to make that also possible that we can reuse these sub-processes on multiple occasions, we created this personnel combining different persons to just one, because we say, okay, from here on, it's the same for everyone. So a generic creation of actors. Then we have signaler. I think also nothing special. That is setting trains, shunting movements, and so on, what we have today. Then we have a stationary device, something that we have in the yards mainly. So an infrastructure-sided device that provides air for the brake test and measurement data. And here we see for the target processes also then the possibility to also enable that with power and data. So that this is also then being automatically connected once we connect with the stationary device. Today it is just with the pneumatics, as you know, and in the future it might be that we have also power and data connected at the same time to steer then also the automated brake test. Then big one, traction unit, of course known to everyone. Nothing so, I would say, so special. But of course, within the definition here of DAC and the full digital freight train, we have to be very specific. Okay, what do we understand with traction unit? What is in, what is out? Yeah, and so here also we described what we see. So we have hybrid couplers, for instance, that can be there. Yeah. We have DPS as a functionality available, which is also part of our project. We have maybe ATO and ASO, so that can be applied, and a traction unit. And this is again here the part that is important for us today. Can be equipped with FDFTO functionality, so that we can retrieve data and so on and interact with the systems. Yeah. Completely fitting in what I just described beforehand, so that we interact with the various FDFT systems that are maybe on the train, but also on the outside, so on the land side. Then something that is really important and I think is good to understand and to know is a non-powered traction unit. So a cold one, as we call it, is considered and behaves like a wagon. I think that's very important. How this is in detail done, here we are in, I would say, in the last stages of defining that. But I think it is just good to say, so once a traction unit is cold and we don't have something here, it behaves like a wagon and can then be taken with the train. So I think for traction unit train, it's something very important. Yeah, units can be main locomotive shunting devices, two-way vehicles, also very important to understand. So if you're looking for, but I have a very specific shunting locomotive, or what for us, this is everything is traction unit. Again, to keep it generic, because otherwise we would have even more actors and very specific ones, and this was not possible. So traction unit combines all these. Then also, I think a very important bit, this is also why it's in bold, the traction unit supplies electrical energy for all the wagons in the train, if that is available. So when we're talking about mainline locomotives, obviously, because we plan to always recharge the batteries on the wagon when we are in train run mode, then it should be there. But for shunting locomotives, this is a thing where we do not see it mandatory, but optionally also possible. If that is possible, then we should always load the batteries and use the power source that is available. But as stated, it's optional. But in general speaking, with traction unit, it is possible to supply electrical energy. And of course, we have some kind of user interface. So then next block, wagon inspector. Something we need, of course, performing the technical inspection of wagons. So technical wagon inspection is done by the wagon inspector. As today, we will see how the new technology will enable us to maybe reduce the task within the technical wagon inspection. This is something we also have a look into, but this is, I would say, also future discussions. At the moment, we just say, okay, we of course have to do the technical WEG inspection. This is why we have the WEG inspector as an actor, and we are doing the technical WEG inspection. So then we have the WEG and WEG set, obviously. Yeah, we have, this is why we call it here both, because we have single wagons, but we also have sets of wagons that are connected. And yeah, I think very easy to understand. I will not explain here more. And then we have yard legacy systems. Also, as we started in the beginning, legacy describes what we already have. So today's systems we are using in our yard operations. Same goes for the yard manager. So the personnel that is responsible for the shunting yards and the yard personnel, same here. So the personnel that is needed for the shunting operation, for uncoupling, coupling, other activities that require human intervention. So that we have what we have also today, the personnel in place once we need them for doing something, for intervene or whatever. So this is also there, and you will see how we use that in the processes. Good. We finally made it through the biggest boring part of the definitions, and the next one is a very important bit again. It's about the assumptions and premises we took to design the processes. Sorry for that. And so let's dive in. What did we think before or when we designed the processes? So what were our assumptions? And I think that's very important. So as stated a couple of times, and this was also in the beginning, what we did, we were already discussing, reflecting on the procedures with a lot of people in the sector, and obviously specifically in transformer. This is what the shells were beforehand. So we were discussing that and back and forth, and it was, you can imagine, believe me, it was hard discussions from time to time to really come to an agreement or to a first common understanding about how we want to do business in the future. So that's what we did. And as stated today, here we are now doing the next step, gaining more feedback and bringing that back into the document and also into the operational processes. Then also, I touched upon this a couple of times already. These processes are designed for the universal usage, so are generic. This is very important because we did not intend to, I would say, tell you guys how you have to do business specifically in your RU and so on and so on. This is not what we intend to do so, but we need a common ground, how we interact with the system, with the newly invented system. And then you have to take these processes that we are giving you now and have to think, okay, what does this mean for me specifically? What does this mean for my daily operation? What do I have to change? How is this different? Is this possible? Is there a problem? And this is exactly what we want to see. So, and this is also what we do as the people that were in charge. You saw DB, RCA, SNCF, SBB, and so on. We are now taking what we created here and checking in our companies now specifically, what does this mean? Of course, they were agreed within our companies beforehand. So what you see is agreed within DB and so on. But the next step now is also for us, it's the same. So we have to take that and make it our own processes. So what does this mean for a specific site? What does this mean specifically for a company like DB Cargo and so on? This is what is possible based on the generic outcome of the processes. And this is very important to understand. And then again, here just again to because it is some time ago, what is not in the document, and I will not go through that again. Here just again mentioned what you will not find in the current state of the document. And then I just say current state because as stated already in the beginning, that will change over time. I also said beforehand that we have, I I will come to the DAC hardware level and FDFT functions definition. And here, let me just also say, before I explain to you what you see on the slides, this is also something that is already, I would say, updated in the meantime. And that you can also see that we are constantly working on improving that, because we are more, and it's already a bit there in this representation. We are a bit moving away from this DAC level, purely DAC level centric description, more to a what is the hardware and what is the functionality that comes with this hardware discussion, to make it more transparent. What do I get when I buy this, or what do I get when I get this kind of hardware? For the document time, that was the definitions and what was available and what was discussed and agreed within the project. So this is what you will find there, but it is also here mentioned, as you can see here, because it's again directly dig out of the document here, that we are still in alignment of the DAC level, and an updated version will be available in another document, in another delivery document of the project. And as you will learn later, we were also planning on an updated version based on your feedback then of this very document of the preliminary operational procedures. And then we will also update this chapter here with the current state. So don't fear that. So we will continuously give you the latest version that is possible to publish, and this will also include this one here. But for the time being, we have, and this is what is then reflected in the document version as you have it now, is the hardware part, which is can be a mechanical coupler, or if we already have that all the time, a mechanical coupler. We have an electrical coupler. We have power and data lines. We have a battery, a central control unit, CCU, as we learned before. We have some kind of emergency handle also there. And we have a lot of functions, sensors, and so on the wagon, if I have really the full picture, so everything on the wagon. And then you have, that is, I think, known to the sector, the different hardware levels, DAC 4, 4, 5, and 5. With the push button here instead of the lever, and DAC 5, of course, just electrical actuation, and we control that with tablet stuff and so on, everything we were touched upon beforehand. So this was just used for the description of the target processes. I think it is, we show how we interact with the system, and you will see the differences, but it is not focusing on this is DAC 4, this is DAC 5 or something, because anyways, we want to overcome these old definitions and base it more on a functional view. I think that is helpful for everyone. And you see the functions that are coming here in general, that is what we are looking for. So the functions, as stated, we described them partially, but this is, because they are in parts and will be developed in other work packages within Transformer. But for the sake of completeness and also to understand what the hell are these guys describing here, what is this functionality, of course, we have a basic description of the functionalities in the document. You will find that also there in the exact same chapter. And the idea of the train functions is are needed to automate and accelerate the train operation, especially in our shunting mode. This was what I was telling before. So shunting mode, that really activates all the full functionality of our FDFT system. And of course, they are controlled and monitored and so on. So this is what we're doing with an FDFT system. So again, this is why I put so many times on the definition part, because otherwise you would be lost now with all these special terms and so on. And users of the functions can be various actors, as we learned before. So locomotive driver, personnel, ATO system, TPS system, and so on, or the leading consist, or the FTEs or an FDFT system. We will see that. So that is what a train function is. and how it can be used. And a very important bit, and this is also why we have it here, to activate the train functions, of course, we have preconditions, preconditions to fulfill from a system point of view. And the validated train composition is one of the biggest precondition that we have. So first we have to check, is that the right train? Is there the right configuration? Is the composition correct? Yes, then the system more or less boots up, to put it very easy now. And then we can use the train functions based on the mode we learned beforehand I'm in currently, and then in a safe and correct manner. So this is a very important bit, that we already have defined preconditions so to activate the functions, and this is really in alignment with the modes that I was explaining beforehand. Here you also find the functions that are available. Of course, just coupling, uncoupling, obviously prevent coupling. We've touched upon this already. Composition detection, integrity monitoring, train length determination, very important. Then automatic brake test, parking brake, EP brake, DPS, and also air management as the functions that are then planned and most of them already in development within Transformer. Now also, and this is then really the last explanation slide before we finally, I know this is hard to get and hard to digest, finally come to a more graphical view on all that. It is the difference between target processes and what we call semi-automated processes. I will also again explain that back and forth now with the processes, but for the start, you need that also as well. So as stated in the beginning, we have target processes describing fully automated operations. So our target picture, everything works fully automated, wonderful future world. But also in the future, we will have not every technology available on each and every site. I think that's for sure. Would be great, but would not be the situation. We have sidings or whatever. We will not have a yard automation system for that. Yeah. So to also have a possibility and also to see that this operation is still possible based on the availability of hardware functionality that I have in front of me when I'm in a different site or whatever, or I'm in a different technology level at the moment, we define these semi-automated processes. So processes that are only partially automated, so can be by the help of the system, but it's not fully steered by a system. So this is why we call them semi-automated, but they may be assisted. In general, of course, I'm always interacting with the new system. So this is why we said, okay, a part of IT of automation is there. This is why we call it semi-automated. So, and the reasons I just explained, it can be technology is not ready. So we are not yet there with that specific functionality, which is described in the target processes, or certain areas are not yet or will not ever be fully equipped with that. And I think that's just accepting the reality that is out there. Yeah, we will not have everything fully equipped with all the systems. And I think this is also something good news, that we do not or did not design processes that require now 20 IT systems in the back end, otherwise you cannot operate. No, this is not the case. So you will see there's always a situation back, and we come to that. And this is made to make it better understandable. To be honest, and in the beginning, it is a bit confusing, especially now when we come to the next bit. And this is I would say the macro view on the document, because you have in the chapter 8 the target processes, and I already touched upon this, the ERGU processes. And you might wonder, why the hell did they describe two processes? The good news first. So the ERGU processes are a subset of the target processes. So once you understand and read the target processes, you by definition also understood the ERGU process. They are not different. They're exactly the same, but one important difference. And the important difference is that we made it transparent in the ERGU processes what will be achieved within FP5 transformer with the technical enablers. And that is the difference. So you will see that, for instance, the FDFTO backend as the full-blown, maybe as a European full-blown system, is not part of the transformer project. And this is why we grade out, and we will see that in a minute, you will grade out these paths, so to say. And by that, we are falling back to the semi-automated state. So to that situation where I do not have an FDFTO backend available. And this is where I would say the circle is closed with the upper definition, because it is a situation that also we will find later on that maybe the backend, for instance, or something is not available. And for that, of course, I always have to have a situation, a processes available without that. And the ERGU processes are exactly the same. It's a subset. Again, it's a subset of the target processes based on the technical enablers. So the things that we will develop within FP5 transformer. That is the difference. The rest is the same. This is also why the definition, the explanations that you will find are exactly the same, or are valid for both processes views. And I think that's a very important thing to understand. So you read the target processes, you understand, okay, this is what they want to do. That is what they described. I can commit. I have a problem with this and this and this chapter. Please give us feedback. And then you can read the ERGU processes and see, okay, what they want to, or what they can reach, what they can require with ERGU FP5. What is the outcome? And then you see how that reflects on the operational procedures. And this is, I would say, that what you can read out of this chapter, which is then after the chapter 8, I think it's 8.5 something, and you can see that there. So that is the very important differentiation here to understand. If there is still problems, because I got a lot of feedback, or we got a lot of feedback here, that this is not clearly understandable. Something maybe also, if there is time, we should discuss then later, or please give us again feedback. Good. Good. Finally, now we have a look on some procedures. And here more or less everything comes together, what I was telling you beforehand. So we need now everything that I was explaining. So we have the definitions in place. So once you read the document, you have a basic understanding. Okay, this is how they define specific things. You know what you will get, yeah. So, and also what you will not get. Migration and so on is not yet part of the document. And then it should be possible for you. Okay, now if I start reading the processes to bring these different chapters that are before that chapter 8 somehow together. So, and this is finally then what you will find in the document. And we have 4 main processes. And the first main process is shunting preparation. And as the name says, is the part where we prepare the incoming train for shunting. Then we have the wagon processing. So this is when we then in the yard doing something with the wagon, processing the wagons over the hump and so on and so on. We will come to the sub processes. These are the gray ones in a minute. There's another slide with the big view, because there's more than that. And we have train preparations. And again, we did everything in the yard. We're preparing for the train run, train preparation. TP, the abbreviation in front means target processes, obviously. And we have EP, these are ERGU processes, so that you can see what's the difference between these two. If you make a screenshot or something, this is why we have here different pronunciation. And then, of course, we have the train run. So we are driving from maybe one yard to another. So the planned train run that is planned for this day with the specific train. And here, of course, we have all the things in place. We can add more wagons by driving from A to B and so on. So what is there in total? And this is what you have here. We have the 4 main processes. That's the green one we had on the slide before. And then we have specific processes for ram shunting. So when we're doing that, we have a specific one for fly shunting. We have a specific one for flat shunting drop off and flat shunting pick up. When you read the document, you will see why we split explicitly flat shunting up, because it's kind of a bit more, and otherwise it was some kind of confusing. And also, if you're not, I would say, so familiar with the differences between ham, fly, and flat shunting, and so, okay, well, what is going on? We also put a very brief explanation of these 3 types of shunting in the document, so that you also can read that and see, okay, this is, and there's also nice sketches done by the SBB guys, so that you really understand, okay, what is the difference and what are they doing. So I think that is also kind of good to mention, that also here we did a bit of background in the document. Then we have the functionalities like automated brake test. You might have read and heard about this. Is also a very, I would say, one of the main functions that that is then possible, that we have a much more faster and nearly fully automated brake test. We have confirm wagon set, something that we also touched upon beforehand, because I said this is very important that we check that as we do today, that the wagon set is exactly that wagon set that was planned to do the next step. So even to go over the hump or to go to a train run or whatever. So we have to check that. And here's a specific sub-process for that, confirming that the wagon set is the correct one and is also in the setting, so in the configuration correct. We have technical wagon inspection. Also, we touched upon this before with the actors. And I said, that of course this is also there in the future, because we need that for safe train run. And so we have a sub process for that designed, and we will see, and this is what I stated also before, we will see how that can be supported, the technical wagon inspection with the new technology, and how we can maybe shorten EZ5 without losing, obviously, any means of safety here, and doing the same, but supported by the new technology. Then we have the additional removal of wagon set, the same also then for the traction unit, something that we of course do in the yard, but also while the train runs. So when we pick up something or we just leave something there in the siding or whatever, how this is working, how the mode change is handled, what to do, also when it comes to brake test and so on, you will find that here. It is also linked to the train run. We have the change of operator, as long as we are not fully in an ATO world. We have, of course, operator, and we have to take that. We have uncoupling and coupling, obviously. So what happens there? We have, and this is why I also spent some time on that beforehand, the secure wagon set against rolling away, something that is really important, that you can safely store the wagons and that they are not rolling away, as the name says. So this is also described here. We have remove released braking means. This again, of course, the same. We have only in the annex. So this is why it's only P, not TP. We have in the annex, you might have seen it already, the bleeding is described. And this is also more or less a supporting process, because we thought we needed, specifically. So we completely designed it. But to be honest, here within this new world, this is not that needed anymore to describe it in depth. because the interaction with the new system is very less. So it's still there, it's in the annex. So if you want to see how the bleeding is designed or how we do it, because it's unchanged, you can find it in the annex. Then we have the parking brake section. So apply and release parking brake, also as the sub-processes that you see, okay, how do we intend in the target processes to interact with the parking brake if available? How is that possible? And how is this linked within the overall processes? You will see that here. And then also we touched upon this before, the FDFTO mode shunting and the FDFTO mode train run. So what is needed? We were talking about preconditions beforehand. What is needed to come from one mode to the other and back and forth and so on? And when do I need which mode? And as stated already beforehand, this is something where we also constantly working on which functionality that is then possible within this mode is available and which not. What do we need from an operational point of view and so on. You might think that this, I would say, black and white, but when you learn about different operations in Europe, you will see it can be really different. And we have to see to find a good, I would say, good way here to design that what is available in which mode, because of course this is here, if I have to change mode, some kind of a performance thing and also safety and so on, and then you have to maybe do other things again and so on. So we have to see that we find a clever way to design that. I think we did a good start, but just stating again, is still in development, and we will see maybe there's a third, I don't know yet. So, and then last but not least, composition detection. So the thing that happens when we connect or we couple and then see, okay, what kind of composition is there? So what kind of wagon configuration, train configuration, total, and so on. That is composition detection, something we need when we're doing the processes. In the document, you will also find a table with some kind of access here in the same chapter. We're now in chapter 8. Where you find the link. So which kind of sub-process do I find or is linked to what main process, so that you also get an overview there if you want to have that. Is also available in the document. Please also have a look onto that if needed. So finally, these are is one of the processes. It's target process number 1, shunting preparation. And you see on the left-hand side, we put the graphic in. It is the one page, yeah, of that. And now what we want to do is we show you, okay, where you find the stuff that I described beforehand, where you find it now here. So the actors we were talking about, these are here on the top, and they're defining the lanes down, which we now will interact. And you see here we have in this target process, we have the yard manager, the yard personnel, the operator, traction unit, wagon or wagon set, and the FDFT backend, because we learned target process, FDFT backend is available. So we think that the FDFT backend then will control the whole process and is available. In the ERGU process, you will find this box is grayed out, and to also make that easier, how these different colors and so on is working. We come to the next slide in a second, but I think it's very easy to understand that if you have the actors above, and if I have a look here on the full picture, the rest obviously then is the process. Yeah, we have the process start here, and how the symbols are working. We have a slide for that as well. And also, I think something in the beginning when you start reading, worth printing it out and putting aside, because until you get familiar with the colors and stuff, it can be a bit hard to read. Yeah, so maybe a good idea to do so. And I would just point here on the most important bit. So target state activity is green. We have the semi-automated state in yellow. We have the ERGU process step in gray, but it is more or less a target state that is grayed out, you know? So it is still there. So it's the same drawing, it's the same process, but it is so to say not active, not valid within this view, but it is the same process. So that everything that you see, it is only a subset. Yeah, so it is a part of that, but it's not active. Then you have these rectangles here, and these indicate the sub-processes. So every time you see that, and we saw that already here, let me jump back for that, you saw that here. This indicates that there is a sub-process, and also the number of the sub-process is also there. And you find that in the upper right corner, and the process ID is also there. Then we have activities with operational necessity. This is activity where we say, hey, this is really, really important to do so. It's mandatory. It must be done. And this is then indicated with a red line around these different ones so that we see that. And the rest, I think it's very easy, start, end, decision points, and so on. The only thing that I was just pointing again, and we will see that, is these, when do we get to the semi-automated activity flows? This is the yellow dotted line. And we will see that now also on the next slide, how this is working. So again, this is the same shunting preparation view as we had on the first slide. Here, or now here, describing where we are at the moment on that very process page. And as you can see, we start here. The train arrived on the target track. Yeah. And now if we are under the situation, we are in the full target processes, we have the backend that controls that. And so we now check additional wagon data and so on. So, and you already see here yellow dotted lines coming in and or getting here to the yellow boxes, which we call semi-automated processes. And the thing is now, if that is not available, or it can be also just one step is not available, then you can always go via the yellow dotted line back to the semi-automated state. And in this case, if I'm talking about confirm the wagon set, for instance, which is also a sub-process as we learned, because it has this rectangle here indicating that. The system can do it, so it can steer the process. And once you dive into the sub-process, you will see that it's then also followed there. Or if that is not available, the operator has to do it and say, okay, this is my confirmed wagon set that I have here. And then the question starts here, if the traction unit is also planned for the shunting operation, yes or no. So for the shunting preparation, sorry, not operation, preparation, yes or no. And then we have these decision points, these blue ones also indicated with DE1, and then they are numbered through to the whole process. And you also will find, we come to that in a minute, descriptions to each and every of these boxes and decision points and so on. Also in the document directly after the process. So with more descriptions and so on to better understand that. So at the beginning, I think when you read that, browse through basic understanding, and then also maybe you have to jump back and forth with the description that are a link to that here. And so we follow that path and saying, okay, yes, we will do so, or no, then we end up here. Then is securing wagon set necessary? Again, as stated, we use this term a lot. So is this done or not? And when we skip now, when we switch now to the next page, you will see. And this is also why I say this is kind of difficult now to explain it here, because you have to go back and forth. We are coming from here at the moment. And so the question is now, if we go to that path, again, go back, we have the possibility to be here or here based on if securing is necessary. Yes, I would say yes, because I'm on the safety side. So we're doing so, and now it's again the question, if the backend can do so by any control, he secures the wagon set against rolling away. So he can command brakes, whatever that they are available, and secures that, and knows then based on the feedback that this is possible. If that functionality or the backend is not yet available, we go back with the yellow dotted lines, and then we have to ask which staff is then is on site. Is the operator alone? So for some reasons, or do we have really yard personnel? And based on that decision, the yard personnel or the operator is doing the securing against rolling away, adjusting the rear end signal, sorry. And then again, you can go back and can see, is that functionality available? So if the FDF backend, so to say, is there, then he switches the wagon set into the shunting mode, a very important bit, or the yard personnel does that. How this is done in specific, you will find, because we again have here the rectangles, in the sub processes. So once you are here from a reading point of view, you come maybe here, and then your eyes come here, and then you have let's call it the yard personnel is there, because we have a big yard with all the personnel. Then when you read secure against set against rolling away for the first time, I think it will be good then also to then now go to 22, sub-process number 22, and have a look, okay, what do they do? What do they intend to do with secures wagon set against roll? What is that? And check that first and then continue. And the same then goes for the other sub processes, so that you really understand what happened in the meantime. Because you might think, now this is really easy described, okay, but what the interesting part is now happening. Why did they not describe? It is in the sub processes, so please have a look into that, and then you will find hopefully all the answers. If not, or if you're missing something, again, please tell us. This is why we're doing this. And as stated, once this is done, we can go back to the FDF backend if you want to, or if this is available. And then we are at the end of the page. And here we indicated here an A, because we just have one line that is ended here. And this is needed for the next one, because you see we have a new page. And the next, to start on the next page, we have the same A again. So that you find, because there can be more than just one, there can be multiple ways of how it can be done on the next page. And so to have that in place, we have indicated here, so that you know, once you have the next page, where to continue with your process. This is then again something which I want to tell you. So we had the A/B thing here as one of the necessities that we have, because otherwise we would have, and the people who were involved in the beginning know, at the beginning we had canvases, really one big poster like stuff to go through, which was really hard to read, and so we completely changed the way of the look and feel to that bit. Of course, we have something like this because we have page changes and so on, but still, I think it's better to read than if we have just one big canvas, because we had that before and it was not good. And the same is here. We have sequences. So if you have these big blue block here, then we have a sequence starting, and it's an independent flow. And just that you see that, and we are continuing. So we are still here coming in at the A. So we are just continuing the example, what we started. And I just put away these blue things so that we can better read it. But it's still here now, the sequence that we have a look into. And you see, we can continue. And again, we have always checking that everything is safe. Okay, again, here, ensure rolling the rolling capability, so that I now can move the wagons within the yard. And so we are checking that and ensuring that, even with the system, with some means, or again with the staff, same as above. And the checking in parallel if the current traction unit is planned for the shunting preparation again. So there might be changes or whatever, but now checking, okay, if the traction unit is also planned for shunting preparation or not. If not, we have to uncouple and have to put the loco aside and get another one. Or if yes, then of course we can directly say, okay, we are ready for shunting, because then I'm done. I don't have to do something like that. So, but this can, and this is what the sequence says, then also be done in this sequence. And it is not a strict first to that, because that can be done in parallel. And here again, we are at the uncoupling and so on. So again, the sub processes that we are calling with these rectangles. So if you read the document, then please jump to P20 and call these and have a look into the uncoupling traction unit process. Then once you find again this gray circle, then this process is done. It's the same with the sub processes. As you can see here, we have the secure wagon set against rolling away target processes, and you see we have the starting point and also the ending points here, and you see if we're coming in here, we're jumping in. We have the situation here that we combine the different the personnel in these personnel, which I explained beforehand, and then you have the same walkthrough. So the look and feel is always the same. Here we also have that we send data, for instance. So this is with these kind of there's some kind of data exchange, in this case with the yard manager. So indicated like this. This is what I was talking about when we said we just started with these kind of which kind of data or thing comes from A to B and so on. But this is the logic that you that you find, that you have a starting point in the sub processes and then of course an end point. And if that links to another one, we have defined it like this, like the A. This was like this, or it is ended like this here, and we continue, and this is what is done with that here. We continue in the main processes, so in the process that was calling the sub process. I think that is the logic here to understand. So once you dive in, you start exactly on the same line where you also coming in. Here the special cases, if you're in the personnel area, that can be then combined here, but this is also explained, and this is why I explained that beforehand. Then you're doing the sub processes. So the left-hand one is not at the moment interesting for you. You're doing your stuff here. You follow the path that you want to see, and then you end up here or here. And then again, you dive in on the same path where you were jumping out, because you should end up also in the same. And then you are here. If you're ending up here, yeah, there's always also the yellow dotted line that also brings you back. So that should be consistent. If not, please also tell us. And then you had a full walkthrough through the process. And with this kind of help and support, it should be possible for you to read through the document and also to read through the processes. I was talking about more descriptions also available. This is what you then find always after the processes that I was just showing you. So have, for instance, you have the target processes 1, and then you have different pages of that. And then you also have the activity description and decision description and so on available directly after that. And here you will find more depth information about this very step, describing preconditions, the conditions that must be fulfilled, task, remarks, rational, post conditions, all that. So more specific information to each and every process step to better understand what we were thinking about by designing it. Also here, please read through that carefully and tell us what is missing. Tell us what you want to have added or whatever. This is really important to get more and more solid picture. And the same goes for the decision description. Also here, describing the different option of the branches we saw earlier, and also what are the what is the reason for that, or again, repeating the possibility you have in each and every branch. Good. So that is, I know, a lot to digest, and this was the walkthrough through the document that is now available or was already available for you. So from me, last words here. Thank you for the time you spent with us today. I know this is a lot to digest. I know that, and this is 300 pages long. Believe us, yeah, it was also hard to write, but I think what we achieved at the moment is a very good first step towards a harmonized operation in Europe with the FDFT. And so it's really up to all of us now, because these are our operational processes. I cannot mention that enough, that we gain more feedback and that you be part of this story. And we're really looking forward to that. And I can really just thank you again for participation today. And before I hand over back to Frédéric, and thank you from the team also already in advance. If you give us feedback, we're really looking forward to that. So thank you for your time, and thank you for listening to my voice for over 90 minutes now. So thank you for that. And then back to you, Frédéric.
Thank you very much, Andreas. A quite difficult exercise, but I think you went through it with your explanation.
I
hope said, it is a quite, I would say, volume to digest, but as well complexity of things to be looked at. So the main topic that needs to be addressed from now, because this is the first time I think we explain and we expand to the world, to the most railway community representation today. It's the way forward, starting from this point in this document that you have been provided and explaining today. So the main, I would say, actions to come, thanks to this first material delivered to you all, is for the, I would say, organization of further works in between the system pillar, task for DAC digital automatic coupler, FDFTO related activities with FP5 and EDDP. So as you can see in the chat, a lot of questions have been addressed. So we may take some time at the end of the webinar to answer some of them, depending on the time that we have left to do so. But the questionnaire, which is designed up until today and will be maybe refurbished to take into consideration the different comments and questions that were posted into the chat, this online questionnaire will be distributed to all the participants today, so that the task force team and the system pillar team in conjunction with FP5 will be able to collect all the question and answers that needs to be considered. So we would like you all, after this distribution of this material, with this support as a PowerPoint document, with the video, and with maybe the bilateral exchanges that we can have with all of you, because since today, I think you all know the contact details that you can reach to be answered with your questions. We would like to be able to collect all the feedback as a first, I would say, step by mid-October this year, so that since we will be able to liaise with the FP5 and Andreas team on the WP2 of FP5, so that they are able to integrate and agree on the incorporation of further explanation and maybe some precisions or some updates on this technical report of today, to have a release of a version 2 by the end of this year. So we understand that it is an ambitious, I would say, program, but since this material is quite important for the, I would say, update of freight activities, we need to get feedback from you and to be really active on this matter. So we are going to follow up this webinar session with addressing this questionnaire, and we would like you to be able to spend the necessary time in order to answer precisely to it, and to be able to achieve with it by the mid of October. So it means within 1 month, we would like to get collection of all the return from your side, so that it's possible for us to I would say, have some material in order to update the technical report from the FP5 Andreas Haller team. Then, since this would be achieved by the end of this year, the work program, which is anticipated, is for the next year, 2024, to be able to be in a position of elaborating a first draft of FDFTO rulebook somehow. So it means on the train operating companies and railway undertaking side, to be able to elaborate an harmonized rulebook, taking into account all the comments and feedbacks that we will have received, so that we reach with an agreed operational set of procedures which are related with the integration of the DAC into the railway system. Here we are not yet precising if it's ERGU or target processes that we are going to discuss on. And this is exactly the kind of things that will still need to be discussed in the frame of the activities to be performed next year, because everything which is related with the operational procedures from the railway undertaking point of view will have to take into account the questions that were raised today, to say, what do you do about the private marshalling yards? How do you integrate these railway operating procedures as an interface within the CCS system or the ETCS operating rules, all this kind of stuff. So you see here a picture which is showing that the main way forward for the rulebook related with the DAC and FDFT operations should be in the scope of the TSI operation. And this is where you see that the system pillar activity needs to deliver some inputs related with the DAC will be in the scope of the TSI OPE, but it will have to be interfaced in a mandatory, I would say, way with the other TSI which are related. So I saw in the chat some questions that were raised about the integration of the modifications on the best channel that needs to be chosen. So it may be the case that it will not be in the TSI OPA related that some modification will be appearing, but in the other TSI related, like for instance, the TSI wagon or the TSI lock and pass, anything which all these topics will be discussed in a frame of an organization and a work plan, which have, of course, to be interacting with the European Railway Agency, with the Senelec body and standardization bodies, and as well with the system pillar actors who are going to, if it's necessary, to deliver some system pillar documents as a matter of, as an output from the E-Rail organization related to FDFT. So in order to do that, of course, we will require to have a mirror group. So as it was explained at the beginning by Jens, for the system pillar task force activity, the EDDP, European DAC Delivery Program, is playing the role or the main role of mirror group for the task force activities. But what we would like to put in place, thanks to the interaction of today with you all, and thanks to the interfaces that we are going to handle and to get the collection and the feedback provided to the work program of the EU Rail activity, we would like to set this mirror group from beginning from today to be participating to the elaboration of this draft of rulebook. So some interactions will have to be organized. The way that it is going to be organized is not fixed yet, because it depends on the level of return that we are going to have, and it depends on the way forwards to organize maybe another webinar or bilateral meetings or dedicated working parties. We don't know yet exactly the framework which will be designed, but thanks to your, I would say, inputs, which are very important, as I remind, we will elaborate this plan in the near future in order to achieve with these goals, I would say. So this is the main message that from the System Pillar Task Force point of view, I wanted to pass, is that since today, a lot of iteration and interfaces will be organized so that we get the feedback from your side, and we get and we achieve with a common view of the future set of rules which have to be elaborated in the frame of full digital freight train operation as a target system. So this is the main message I wanted to pass, and then it's over for my part. So I would ask maybe Jens to get the concluding words, so that he, as an EDDP co-manager, knows and maybe will remind the importance of you on board. Please, Jens, go.
I am very impressed about today, to be honest. Yeah, I don't know if this is also a good thing of the digital age. I don't know if we could have hosted. I think we had 300 something participants at the in the peak point. I don't know if we would have had all this space in the UIC building for such a conference.
No, I don't think
so. For me, this is a tremendous success in interest. It's the first time that we all do it here. Special thanks to Andreas. I mean, I think you have shown what the French call une certaine maîtrise de sujet. So you know what you were talking about. And I hope that it was not too demanding for all the participants, but I mean, it has to start somewhere. And I think you made also a big effort to try to make it a little bit visual, to, you know, didactic. And maybe there's also then, maybe we have further comments on that and it will evolve over time. But it was a very good start on this. And thank you very much. I think this digital age will also really help to gather your feedback in the following rounds. Very important, this mirror group that Frederic said, yeah, because we need, then this is why we come to you. This is the feedback. And thanks for you asking all these questions. What we decided on the questions, we could have now taken 1 more hour to discuss them all, but to be honestly, there are a lot of questions, and I like them. You know, they touched on the definitions on terms, and where we have already something in TSIs. Question on non-European countries, if we have integrated all the right places, yards and terminals and harbors and so on. You have maybe seen that. Some technical questions, the inevitable questions on how this will be migrated and why we have processes fully automated and semi-automated. Yeah, it's also something that will come up, and interconnection with other TSIs. And the last question I liked here on the ECM. Because the ECM and EMC both is important. Yeah, the electromagnetic compatibility, this is technical, and then later on the relation also. This is big stuff here. And if you think that this was complicated, I mean, maybe it's just because the processes that we see every day in manual operation are not documented like this, but they are also happening in such a way of train preparation and checking and uncoupling and so on. So maybe then if you write the today processes, the document is maybe even longer that we've seen. But that means that the team will take care of all your questions and compile the answers on that, right, Jo?
Yeah.
We'll provide that along the way that Frederic said, and I would be very happy. I think we all would be very happy, including here Javier Joint Undertaking, if this would be the start of a journey where in the end we have informed everybody better. We have gathered the feedback that we wanted to have, that we jump into the point, that we directly come to the buffer stop here and not derail somewhere else. And exactly this is it. And from my side, I can only say thank you. That's the only conclusion. It's a good format. I think if you have any suggestions to do there, please send them to us. We will try to integrate them. The colleagues will try to integrate them. And I mean, in the next peaks, we want to have 1,000 participants then. Yeah.
Don't forget that the Teams tool does not allow more than 1,000. Yes.
Oh, yeah, okay, good. Okay, but maybe that's even the relevant.
So we should have some space.
Yeah, good. And thanks also for not using all the time. I think if everybody can go to lunch a little bit earlier, everybody will be happy. So bravo and many thanks. Yeah.
Thank you for your participation. Maybe last words from Javier. You want? Yeah.
Just to emphasize on the message that Jens, Andreas, with the technicalities already provided to the broad stakeholders here present today. To encourage your participation, to send your comments, feedback. I mean, as you have seen by the presentation, required technical expertise will be needed to go through that and provide content that can be really considered later on for the update on the deliverable, and that was the intention, and we hope that with these thorough explanations and with the material that you will have available, we can get your inputs by these deadlines that Frederic was stating. So thank you very much for the preparation, the presentations, and for attending the webinar today. Thanks.
Thank you very much. So from my side, I would say best congratulations to Andreas, because that was the most complex, I would say way forward to explain. But as I said before, the further steps are going to be defined thanks to your feedback. And then from this webinar number 1 today, not knowing yet what's going on in the near future, there will be some sessions organized. As I said before, we have deadlines, we have milestones in front of us, and we need to get the sector with us with the achievement of this transformation of the railway system, so for freight. So definitely, I would say thanks for your participation, and I would say see you soon.
Exactly. Thank you, everyone. Bye-bye. Have a good day.
Thank you. Bye-bye.
Thank you to all, and have a good day. Thank you.